Cambridge IGCSE, October-November 2021, Physics 0625, Paper 43. Question 1. A ship sails in a straight line between two ports. Figure 1.1 shows the speed time graph of the ship for the first 100 minutes of its journey between two ports. So in this question we are provided with speed time graph. Part A. Calculate the maximum acceleration during the first 100 minutes of the ship's journey. So from a speed time graph, we need to find out maximum acceleration. So here first thing we need to know is, if we have a speed time graph, in order to find the acceleration of that particular motion, we just need to calculate the gradient of the graph. Gradient or slope. So from a speed time graph, we can find out the value of acceleration simply by calculating the gradient of the graph. So here also we just need to find out maximum acceleration. Therefore, we can calculate maximum acceleration by calculating the maximum gradient of the given graph. So, by looking at the graph, we can understand the maximum slope is during the section from 40 to 60 seconds. Here we can see a maximum slope. So, this gradient will give you the maximum acceleration of the motion. Therefore, we can find the gradient of the graph during the section 40 to 60, and the equation of gradient is y2 minus y1 over x2 minus x1. So now we can find the values of y1, y2, x1, x2 from the graph carefully. So first we can find out x1, the starting point of this section on x-axis is x1, and which is 40, but we should be very careful that the unit given on x-axis is minute, but we should always substitute the value in an equation in its standard unit, that is in second. So we should convert this minute value in second. In order to do the conversion, we should multiply the value with 60. So x1 is actually not 40, but 40 times 60. This is the x1 value in seconds. Likewise, we can find out the corresponding x2 value on x-axis. So we will get x2 is 60. Again, here also we have to convert into seconds. So we just need to multiply again with 60. So we got the x1 and x2 value. Now we need to find out the corresponding y1 and y2. So in order to find the y1 value, we can extend this corresponding point of x1 on the graph to y-axis. So we can identify y1 is 6.75, and the unit is given in standard unit, so we don't have to convert the unit on y-axis. Now we can find out the y2 value, and it's very clear, y2 is 15. So we have y1, y2, x1 and x2 values. We can substitute in the equation. So y2 is 15 minus y1 is 6.75 over x2 is 60 times 60 minus x1 is 40 times 60, and the answer is 0.0069. So we can write down maximum acceleration 0.0069, and the unit of acceleration is meter per second square. Part B. Calculate the total distance travelled by the ship between the time 42 minutes and 100 minutes. So from the speed time graph, we need to calculate the distance covered during the given time interval. So let's go back to the graph again. Again, from a speed time graph, we have to find out the distance covered. In first part, we had to find out the acceleration, but in the part B, we need to find out the distance covered. So we need to know that from a speed time graph, we can calculate the distance covered by calculating the area under the graph in the given time duration or time interval. So just find the area under a speed time graph. We will get the distance covered. And the time interval is given between 42 seconds to 100 seconds. 42 minutes to 100 minutes. So let's look at the graph, and we can find out that the first box after 40 represents 42 seconds and the last box represents 100 seconds. 100 minutes and 42 minutes. So we need to find the area under this section. So I'm just extending this line so we can identify. We need to find the area of the graph only under this section. Here we need to find the area of this section, the area under the graph. In order to calculate this, we can divide this section into different shapes and calculate the area separately. Then find the total area by adding all individual sections. So now we can consider the first section, this as a rectangle, and we can calculate the area of this rectangle using the area equation of a rectangle, length times breadth. So we can calculate the area of the first section coming under this graph. Then we can calculate the area of this small triangle which is also coming under the graph separately using the equation half BH, that is the area equation of a triangle. And we have one more green section. So by calculating all these area individually and adding all these together, we can calculate the area. So first we can calculate the area of the rectangle, then area of the triangle, then the area of the second rectangle. So first we need to write down total distance is the area under the graph. So first we can find the area of the triangle, where the area of triangle equation half b times height, where base is represented by this length, that is 60 minus 42 times 60. We should convert into seconds also, and height represented by this line, and which is equal to 7.5. So for the triangle we can write half times base value is 60 minus 42, that is 18 times 60 times height is 7.5. Therefore in the given working space, first we can write half times 18 times 60 times 7.5. This is the area of the triangle plus area of the first rectangle, that is shaded with red highlighter. For this rectangle, the length is 100 minus 42, so that is 58 times 60. So this is the length. Likewise breadth is 7.5. So we can write 58 into 60, that is the length, times height is 7.5. This is the area of one rectangle and the area of the green shaded rectangle, where length is 100 minus 60, that is 40. When we convert into seconds, 60 times 60, so that is length, and breadth is 7.5. So we will get 40 times 60 times 7.5, and we will get the answer 48,000 meter. So in two significant figure we can write 48,000 meter or 48 kilometer also correct answer. Part C. At a time not shown on the graph, the acceleration of the ship is 0.0087 meter per second square. The total mass of the ship and its passengers is 2.3 times 10 to the power 7 kilogram. So we are provided with the acceleration and the mass. Calculate the resultant force on the ship. We need to find out the resultant force. Here we can use the equation which relates force, mass and acceleration, that is F is equal to ma, where mass is provided and acceleration is also provided. Therefore, we can directly substitute. So, mass is 2.3 times 10 to the power 7 times acceleration is 0.0087. And the answer is 2 times 10 to the power 5. So, the force 2 times 10 to the power 5 Newton. Part 2. Explain why the force on the ship due to ship's engine is greater than the value calculated in C1. So we have calculated the resultant force acting on the ship is 2 into 10 to the power 5. But in reality, the force due to the ship's engine must be something greater than this resultant force. Or the ship should exert a force which must be greater than the resultant force on the ship. What is the reason? So we know that there must be water resistance. So in order to overcome that, ship has to produce some force extra also. So we can write down, there is a backward force due to water resistance. Figure 2.1 shows a simplified version of a gravity lamp. This apparatus is used to light a light emitting diode without main electricity. The load of 12 kg is raised to a height 1.7 meter above the ground. The load is connected to a pulley system. The time taken for the load to fall the ground is 1200 seconds. The load falls at a constant speed. The generator is connected to an LED. Calculate the rate of transfer of gravitational potential energy. So in this question we are provided with the mass of the load and which is rising to a height. So the height is also provided and time is given. We need to calculate the transfer of gravitational potential energy. Rate of transfer of gravitational potential energy. This is very important. Not simply gravitational potential energy but rate. So rate of transfer of gravitational potential energy is nothing but the gravitational potential energy over time taken. So rate means we just need to find how quickly, or we have to divide that quantity here, gravitational potential energy, with the time. So we will get rate of that physical quantity. Now we know the equation of gravitational potential energy, that is mgh over time. We are provided with the values we can substitute. So m is 12 times g is gravitational field strength, which is constant, that will be 10, which won't be given in the question but you are supposed to know, times height is also given. The height of the object is 1.7 meter. This is gravitational potential energy. In order to find the rate of the transfer of gravitational potential energy, we just need to divide with the time, and time is already given in 1200. And the answer is 0.17, since it is energy over time, that is nothing but power we have calculated. So the unit is watt. So we can write 0.17 watt. Part B. The light output of the LED is 0.10 watt. Calculate the efficiency of the gravity lamp. So we are provided with the output power or the light output. That means the useful output power is provided. And in the initial part, we have calculated the total input power or the total power giving into the system or converting from gravitational to electricity, which is 0.17. The total output power or useful power in the form of light is given in this section. We need to calculate the efficiency. So we can write the equation of efficiency first. So efficiency is useful output power over total input power times 100. You have to memorize this equation. Now we can substitute the useful output power is 0.10 over total input power we have calculated in the previous section, that is 0.17 watt times 100, and in 2SF we will get 59. percentage. So we can write for efficiency is 59%. Part C, suggest a social or environmental advantage of using a gravity lamp. So here we know that how gravity lamp LED is working. We don't need to use any electricity or any fuel. It is just we are converting gravitational potential energy into electrical energy so that we can save the environment, because when we are using electricity directly, we have to consume fossil fuels for the generation of electricity. Therefore, we can write no use of fossil fuel. You can write any sensible answer like no air pollution, no greenhouse gases, does not contribute to global warming. Anything related to this pollution you can write in order to score mark. Question 3, Part A. A gas bubble is released at the bottom of a lake. Atmospheric pressure is 1 into 10 to the power 5 Pascal. The density of the water is 1000 kilogram per meter cube. The temperature of the water in the lake is constant. Part 1. The gas bubble rises to the surface. The volume of the gas bubble increases as it rises higher in the water. Explain why the volume of the bubble increases. So we have a lake here, and there is a gas bubble at the bottom of the lake which is having a pressure pressure is not given, but the density of this water is given, that is 1000 kg over meter cube. Now this gas bubble rises to the surface, the volume of the gas bubble increases. So when this gas bubble rises to the surface, its volume will be more. We can compare the size. So at the top of the lake, the volume will be more, and at the bottom of the lake, the volume of the gas bubble will be less. We need to write the reason. So here we can see the pressure acting on the bubble when it is at the bottom of the lake is the sum of the pressure of the atmosphere plus this pressure of the water. So the total pressure is more when the bubble is at the bottom of the lake. But when the bubble is at the top of the lake, only pressure acting is the pressure due to atmosphere. So we can understand the pressure acting on the bubble is more when the bubble is at the bottom of the lake. So first point we can write pressure decreases as the gas bubble rises. Now we have to write down when pressure decreases, what will happen to the volume? What is the relation between pressure and volume? We can write as pressure is inversely proportional. This relation is very important. This is based on Boyle's law, but we don't have to mention the law here. We just need to write as pressure is inversely proportional to volume. When pressure decreases, volume will increase as pressure decreases or when the bubble rises. Part 2. The volume of the gas bubble is 0.40 centimeter cube when it is 3 meter below the surface of the lake. Calculate the volume of the gas when it is 0.5 meter below the surface of the lake. In this question, there is an air bubble which is 3 meter below the surface of the lake. So we can consider the height or the depth of the air bubble, initially H1 is 3 meter and its corresponding volume is given. So we can consider it as V1, that is 0.40 centimeter cube. Then the position of the bubble is changed. Now the bubble is only 0.50 meter below the surface of the lake. So the new height, that is H2, which is only half meter or 0.50 meter, and we need to calculate what will be the new volume of this air bubble V2. So we can calculate V2 using the Boyle's law equation, that is P1 V1, that is the pressure and volume product will be always constant. of any gas. So we can write P1 V1 equal to P2 V2, where we need to calculate V2 and V1 is already given. P1, that is the pressure at level 1 and pressure at level 2, we can calculate. So the pressure at a level will be the pressure due to the atmosphere plus the pressure due to the fluid. That means the pressure at particular level is the pressure due to atmosphere, which is given in the question. In the previous section, pressure due to atmosphere or atmospheric pressure is 1 times 10 to the power 5 Pascal plus pressure due to fluid. We can use the equation density times gravitational field strength times the depth or the height of the water level above the air bubble. So we can calculate P1 or pressure on the water bubble when it is at its initial position. This is P1. So P1 will be again the pressure, atmospheric pressure, that is 1 times 10 to the power 5 plus the density of this water, which is given 1000, times the G value gravitational field strength 10 times the height or the depth for this position is H1, which is 3 meter. So we can substitute that value. So this is the pressure on the air bubble when it is initially at position 1. Likewise, we can find the pressure when the bubble is 0.50 meter below, that is P2. Again, atmospheric pressure, which is 1 times 10 to the power 5 plus the pressure due to the fluid above the surface of the bubble. We can use rho GH, rho density of the liquid, that is 1000 times G gravitational field strength, that will be always 10 times the height is 0.50. So now we have P1, P2 and V1 also we have. Now we can substitute in this equation here. So we will get P1, that is we already calculated here. We can substitute that in the place of P1. So the P1 is 1 times 10 to the power 5 plus 100, 1000 times 10 times 3, that whole times V1 is 0.40, that must be equal to P2. Again we have, that is 1 times 10 to the power 5 plus 1000 times 10 times 0.50, that is P2 times V2, which we don't know, we need to calculate. So we have, in order to calculate V2, we can make V2 as a subject. Therefore we will get V2 is equal to whatever in LHS we can keep it there, that is 1 times 10 to the power 5 plus 1000 times 10 times 3 all multiplied with 0.40 divided with 1 times 10 to the power 5 plus 1000 times 10 times 0.50 whole, that is will be the answer. So we have to find this value and the answer is 0.50. So the unit given here is centimeter cube, so we can write the volume is 0.50 centimeter cube. Part B, figure 3.1 shows a diagram of a hydraulic press used to compress papers for recycling. When a force is applied to piston A, it causes a pressure in the oil. This pressure produces an upward force in piston B. As piston B moves, it compresses the paper. So the working of this hydraulic press is explained in the question, that when a force applied, this force causes a pressure in this oil, and due to the pressure in the oil, there will be an upward force acting on the piston B, so that the piston B will move upward and it will compress the papers inside here. Let's continue reading the question. A small quantity of air leaks into the oil. So there is air also present in the oil. Suggest and explain the effect of air has on the operation of the hydroelectric press. So we need to express or explain when the pressure increases, what will happen to this air which leaks into the oil. So here we need to understand if there is air present in the oil, when we applied force, some of this force will use to compress the air also, so that the volume of air will reduce. So all the energy we have used to apply the force in order to compress the paper are not converting to compress the papers, but few of the energy is used to compress the air also. So from the force applied, few of the energy is using to compress the air, and the remaining force is only used to compress the papers. Therefore we can write, since it is 2-mark question, we just need to write 2 points. So first point we can write, paper is not compressed as much as the force applied. The reason is few of the force is used to compress the air. Some of the energy used to compress the air instead of paper. Part 4. Explain what happens to the pressure of a constant volume of air when the temperature of the air increases. Use ideas of momentum of molecules in your explanation. So in this question we need to explain in terms of momentum. When the temperature of the air increases, what will happen to the pressure where the volume is constant? So we have to find out what is the relation between temperature and pressure where the temperature increases. So what happened to pressure of a gas? That is the question, and we have to use the term momentum in order to explain this answer. And there should be 4 points in the answer in order to score 4 marks. So the first point is, whenever the temperature increases, the molecules started to move faster. So the kinetic energy of the molecules will increase. So as their speed or kinetic energy increases, they collide with the walls of the container more frequently. So we can write more collisions with the walls in a given time. So more collisions mean more change in momentum. So here we need to know, when a molecule collides with the wall, it rebounds. It changes its position or direction of motion. So that definitely the momentum of this particle will change as the direction changes. So every time when a molecule hits the wall and it comes back or returns, its momentum changes. There is a change in momentum. That's why in the second point we are writing more collision with the wall. So definitely more change in momentum, as we have seen it here. At each collision there is a change in momentum, as there is a change in direction. And we know that when the temperature keeps increasing, definitely more collisions will be there, or more change in momentum will be there. And next point is very important. As momentum or change in momentum increases, we should understand the force will also increase, and when the force increases, it will increase the pressure. So these physical quantities are related. Whenever there is a increment in momentum, that means the force exerting on the wall is also increasing, so that the pressure is also increasing. So this relation of these 3 physical quantities are very important, and you should always include this point for this particular question, where you have to explain when temperature increases or volume decreases, what happens to the pressure of a gas? So this is very important point. First point we can write, temperature of air increases, so kinetic energy increases. Molecules collides with the walls of the container, causes the change in momentum of that molecules as its direction changes. When it hits the walls, it bounces back. So third point we can write, when temperature increases, change in momentum also increases. Because in the question it's mentioned temperature of the air increase. So we should write, when temperature increases, what happens to the change in momentum. And the last point is very important point. As the change in momentum increases, we can write the force increases, hence higher pressure. So in this question, the important keywords are kinetic energy increases, molecules collide with the walls, the collision with the walls causes a change in momentum, higher force causes higher pressure. These all are the keywords you should include in order to score full mark. Question 5 part A. An aluminium saucepan and a steel saucepan have the same dimensions. Table 5.1 shows the values of specific heat capacity and density of aluminium and steel. The mass of the aluminium saucepan is 0.41 kg. Calculate the mass of the steel saucepan. So here we need to calculate mass. So we can use the equation density is equal to mass over volume. And in order to calculate mass, we can make mass as the subject. So we will get mass is equal to density times volume. So here we need to find the mass of steel, where the density of the steel is given, but volume of the steel is not given. So we need to calculate the volume of the steel. But there is very important information is given that the aluminium saucepan and steel saucepan have the same dimension. That means the volume of aluminium and volume of steel both are equal because they both have same dimension. So here we can find out volume of steel by calculating the volume of aluminium. The reason is, as the volume of steel is equal to volume of aluminium, because it's mentioned they both have the same dimension. So in order to calculate volume of steel, we can calculate the volume of aluminium also. So the volume of aluminium is nothing but the mass of aluminium over the density of aluminium, and with both these values are given. Mass of aluminium is 0.41, so we can substitute 0.41 over density of aluminium is 2600. So this is the volume. Now we have volume. We can substitute these values in the main equation of mass. So mass is equal to, mass of steel is equal to density of steel times the volume of steel, where density is already given 7600 and volume we have calculated by calculating the volume of aluminium, as both values are same. So we can substitute in the place of volume it's 0.41 over 2600, and in 2SF the answer is 1.2 kilogram. So we can write mass of steel is 1.2 kilogram. Part 2, calculate the thermal capacity of aluminium saucepan. So the equation of thermal capacity is mass times specific heat capacity. So the mass of the aluminium is already given, that is 0.41 times specific heat capacity of the aluminium is also given, that is 0.91. So we can substitute that and the answer is 0.37. We have to write the unit. So the unit of thermal capacity is joule per degree Celsius. We can memorize this unit of thermal capacity by the definition of thermal capacity, as thermal capacity is the energy required per temperature to increase. So that we can easily memorize that the unit of energy is joule and unit of temperature is degree Celsius. So by combining these, joule over degree Celsius is the unit of thermal capacity. Therefore, we can write 0.37 joule per degree Celsius is the unit and the answer of thermal capacity. Part 3. Water is heated in a steel saucepan. The initial temperature of the water and the saucepan is 20 degrees Celsius. Calculate the energy transferred to rise the temperature of the steel saucepan to 100 degrees Celsius. So we have to calculate the energy required to change the temperature from 20 degree to 100 degrees Celsius. So here we can use the equation of specific heat capacity and energy, that the energy required is equal to the mass of the steel times specific heat capacity of the steel times the change in temperature, where mass of the steel we have calculated already in the first part, that is 1.2. So mass of the steel is 1.2 times specific heat capacity of the steel is already given in the table, that is 0.50. So we can substitute in the place of C or specific heat capacity of steel. It's 0.50 times change in temperature. We can understand the temperature should increase from 20 to 100 degree. So the change is 100 minus 20. So we will get 1.2 times 0.50 times 80. And the answer in 2SF is 48 joule. So we can write 48 joule. Part B, explain why metals are better thermal conductors than non-metals. So we can write metals have more free electrons. Free electrons mean they are not inside the atom, or they are available inside the metals and they are free to move throughout the metal. So these free electrons transfer thermal energy as they can move freely, which transfer thermal energy. Question 6 part A. Describe an experiment to determine the speed of sound in air. State the apparatus you need, details of how to take measurements and how to calculate the speed of sound in air. You may use the space below to draw a label diagram as a part of your answer. So basically we have to describe an experiment where we should show how to take the measurement and how to calculate the speed of sound in air. So in this experiment we can keep one person at one's end and he should produce us a sound, and certain distance away we have to keep a wall, and you should label it as a reflecting surface or a wall. Let the distance between this person and the wall be x. And in order to measure this distance, we can keep a measuring tap in between. You can label it as measuring tape. Next important thing we need here is a timer. So he should keep a timer with him. So let it be digital timer, doesn't matter. And we should label it as a timer also. So these are the important components we required to do this experiment. Now the first step, he should produce a sound. Then this sound will travel from the person to the wall. As from the wall, the sound wave will reflect back and he should be able to hear the echo. So when he produces the sound, he should start the timer, and when he hears the echo, he should stop the timer. So from the timer he will get the time taken by the sound wave to travel from the person to the wall and again back to the wall from the person. So with the help of the timer we have the time taken, and with the help of the ruler or the meter ruler we have the distance traveled by the sound wave also. And the total distance between will be 2 times x, because we know that it is echo which has to travel double the way, because the sound wave should come from the person to the wall and it returns back. So the distance is actually 2 times the distance between the person and the wall. That is also important. Now we have distance and time. We can calculate speed using the equation. Speed is distance over time. So now we have to explain this experiment. So we can write. So first point we can write, person produces the sound and after reflecting back from the wall, he can hear his echo. Now we have to explain how to take the readings. Next we can write, start the timer when he produces the sound and stop the timer when he hears the echo. Next we can mention about the distance. So we have to measure the distance traveled by the sound wave using a meter ruler. Now we can write the equation that then the speed is nothing but the distance, where actually the distance should be 2 times distance between person to wall. The reason why we have to double, since it is echo, the sound wave will travel double the way. It will travel from the person to the wall and it will return back from wall to the person. So we have to multiply the distance between the person to wall with 2. So that will be the total distance traveled by the sound wave divided by the time taken, which we already have with the help of the timer. So these are the important points you should include in order to score 5 marks. You should have a labeled diagram with this explanation and the equation is also important. Part B. Sound waves from a television are diffracted through doorways. Light waves from the television are not diffracted through doorways. Suggest why light waves and sound waves behave differently in this situation. So here in the questions mentioned that the sound waves diffracted through doorways, but light waves are not diffracting through doorways. What is the reason? So here the first thing we should know is, in order to have a best diffraction, the important condition is the wavelength of that wave, whether it is sound wave or light wave, that must be equal to the gap width or doorway width. So for any wave, its wavelength is matching with the width of the doorway, then such waves will diffract. So the wavelength of the sound wave is always almost equal to the width of the doorway. That is why the sound wave always diffract through the doorways. But when you compare the wavelength of the light waves, which is much smaller, when you consider the wavelength of light waves, which is very, very smaller comparing to the doorway width, so it is not satisfying the condition to have a diffraction, because the condition for the best diffraction is this one, that the wavelength should be equal to the gap width. So this is the reason. So first we can write the condition to have a better diffraction. So first we can write wavelength must be equal to width of the gap for a maximum diffraction. This is the condition we can write for all the questions related to diffraction. Next we can write wavelength of sound is similar to the width of doorway, but wavelength of light is 2 or much smaller than the width of the doorway. These much points are important to score 2 marks. So we should compare also the wavelength of sound and wavelength of the light waves with the width of the door width. Question 7 part A. Figure 7.1 shows a ray of green light emerging from one face of a glass prism. Part 1 on figure 7.1, draw the path of green light entering and passing through the prism. So we have to draw this green light before it enters the prism, and when it is passing through the prism, what should be its path? we have provided the ray of green light when it is emerging from the prism. So initially we can draw the normal. Normal is very important, then only we can understand when it is when it is refracting, whether it will bend towards the normal or away from the normal when wave is traveling from denser to rarer or rarer to denser. So drawing the normal, that is nothing but perpendicular line on the surface, is most important. So we have to draw a perpendicular line from the surface. So this is the normal at the surface. So the green light must be passing in a path something like this, because we can see as the ray is passing from denser medium to the rarer medium, the ray will bend away from the normal, so that the angle of incidence here and angle of refraction here, the relation must be angle of incidence should be smaller than the angle of refraction. The reason is, at this surface the light is traveling from denser to rarer, because the prism, inside the prism the density is higher, outside the prism it is air, so the density will be lesser. So it has to satisfy this particular condition. But at this surface we can see the green light is passing from air to the prism. That means rarer medium to denser medium, or less density medium to high density medium. In that case, angle of incidence will be greater than angle of refraction. So we have to draw the incident ray here accordingly. That should satisfy this condition. So the second thing what we have to do is we have to draw the normal again first. Normal is nothing but a reference 90-degree line from the surface of the prism. So this is the normal, which makes 90 degree with the surface. You can take a protractor and draw the normal. When you draw, you have to make sure this angle between the surface and the normal should be 90 degree. So we have to draw the normal first. Next we should draw an angle, a ray of incidence, which should satisfy this condition. So we can draw a ray something like this. Now we can see, in this case angle of incidence is the angle between the incident ray and the normal is greater than the angle of refraction, angle between the refracted ray and the normal. So this is the green light which is entering and passing through the prism, and it's very important to put arrows to indicate the directions. Part 2. The green light is monochromatic. State in terms of wave property what is meant by a monochromatic light. So monochromatic light is a light in which all the light waves will have same frequency. So all the waves will have same color. So we can write light of single frequency is called monochromatic light. Part B. First part, state the speed of light in air, which is a constant value, and speed of light or speed of all electromagnetic waves is same, that is 3 times 10 to the power 8 meter per second. Part 2, the wavelength of green light is in air is 5.2 times 10 to the power minus 7 meter. Calculate the frequency of the green light. So here we can use the wave equation, that is speed of a wave is the product of frequency and wavelength, where speed of the light we already know, that is 3 times 10 to the power 8, which is not given in the question, but we should understand it is always constant in vacuum and air, that is 3 times 10 to the power 8, and Wavelength is also given, that is 5.2 times 10 to the power minus 7 meter. So in order to calculate frequency, we can rearrange this equation and make frequency as a subject. So we will get frequency is speed over wavelength, where speed is 3 times 10 to the power 8 over wavelength is 5.2 times 10 to the power minus 7. And the answer in two significant figure is 5.8 times 10 to the power 14 hertz. So we can write 5.8 times 10 to the power 14 hertz. Don't forget to write the unit in order to score full mark. Part 3. The refractive index of glass for green light is 1.52. Calculate the speed of green light in glass. So the refractive index N is given. So here we can use the equation of refractive index, that is refractive index of glass will be equal to speed of light in air over speed of light in glass. So in order to calculate speed of light in glass, we can make speed of light in glass as the subject. So we will get speed of light in air over refractive index, and speed of light in air C, which we already discussed, that is always constant, 3 times 10 to the power 8. Our refractive index is already given, that is 1.52, and the answer is 2 times 10 to the power 8 meter per second. So we can write 2 times 10 to the power 8 meter per second, and you have to be careful while writing the answer. You should write 2.0, then only it will be in two significant figure. If you are writing the answer like 2 times 10 to the power 8 meter per second, you won't get 1 mark for the answer, because 2 must be written in two significant figure. So you should always write 2.0. That is very, very important. Question 8 Part A. Figure 8.1 shows two charged metal plates with a gap between them. The plates are parallel to each other. The top plate is negatively charged and the bottom plate is positively charged. On figure 8.1, draw 5 electric field lines between the two plates. So we have two parallel plates. One is negatively charged as shown in the figure, and another plate is positively charged. So we know that as they are charged, there will be electric field between these two plates. Here we have to draw 5 electric field lines. So we should know the direction of electric field lines first, and it will be always pointing towards the negative charge. So the field lines arrow must be always directed to the negative side from the positive side. So this is something you have to always remember when you draw an electric field line. Its arrow must be from positive charge to negative charge. And in order to draw these 5 electric field lines, you should use a ruler and pencil, because the lines should be always straight lines equidistant away. So by taking the ruler, let's draw 5 straight lines. You have to make sure the separation between each line should be equal, as there is an equal or uniform electric field. And we have to put arrows also in order to indicate the direction. As I already mentioned, it should be always pointing towards the negative charge. Part B. An electric iron has a power of 2400 watt. The potential difference of the main supply is 220 volt. Calculate the electric current of the iron. So we are provided with power and voltage. We need to calculate current. Here we can use the equation which relates power, voltage and current. That is, power is the product of voltage and current. In order to calculate current, we can make current as the subject. So we will get current is equal to power over voltage, where power is 2400 over voltage is 220, and the answer in two significant figure is 11 ampere. So the current is 11 ampere. Part 2. Calculate the electric charge which flows through the iron in 15 minutes. So here we have to find out the charge Q where the time is given. Time is 15 minutes. That means time is 50 times 60. Because time is given in minutes, so we need to convert into seconds. That is very important. So time is 15 times 60. That is 900. And we have current which we have calculated in the previous section, which is 11 ampere. And in order to calculate charge Q, we can use the equation of current. That is, current is nothing but the charge over time. So in order to calculate charge, we can make charge as the subject. So we will get charge Q is equal to current times time, where current is 11 times time is 900 seconds, and the answer is 9900 coulomb. So we can write 9900 and the unit of charge is coulomb. Part 3. Fuse rating of 3 ampere, 5 ampere, 10 ampere, 13 and 30 ampere are available. State which of these fuse rating is suitable for the use of iron. So here we know that the current passing through this is 11 ampere. So if we cannot use any fuses, its value is less than 11 ampere current. So we can use 3 ampere, 5 ampere or 10 ampere because there must be a current flow minimum 10 ampere. And 30 ampere also something which is too much greater than the current which is flowing through the iron, that is 11 ampere. So the suitable one is 13 ampere. The 13 ampere is the fuse value which is close and higher than the current passing through the iron, which is 11 ampere. We have already calculated. So we can write proper fuse rating must be a 13 ampere fuse. Question 9. Figure 9.1 shows the current potential difference graphs for a resistor, thermistor and a filament lamp. The resistor, the thermistor and the filament lamp are connected in series with a power supply. Draw a circuit diagram for this circuit. So we should draw a circuit diagram where there should be a thermistor, a resistor and a filament lamp. All should be connected in series with a power supply. So there must be totally 4 components: resistor, thermistor, filament lamp and the power supply. So first we can draw a power supply because that is the most important thing required for a electric circuit. Then we can connect with a resistor. So we need to know the symbol of a resistor. Then a thermistor. So thermistor is also again a resistor, but its value changes with temperature. So the symbol of thermistor is like this. Then a filament lamp. All we have connected in series. Series means end-to-end connection. Now we can complete this circuit. We can label every component in the circuit also. Part 2. Add a voltmeter to your circuit diagram in A1 in a correct position to measure the potential difference across the resistor. So in order to calculate the potential difference across the resistor, we should always connect the voltmeter across it. So it must be, voltmeter connection should be always parallel or across that particular component. So this voltmeter will give you the value of the potential difference across this particular resistance. Part 3, using the graph in figure 9.1, determine the potential difference across the terminals of the power supply when the potential difference across the resistor is 6 volt. So this point is very important. When the voltage or potential difference across the resistor is 6 volt, we need to find out what is the voltage across the power supply. So let's go back to the graph. So first it is provided that when the voltage across the resistor is 6 volt, we can find out what will be the current flowing through the circuit. So let's look at the graph of the resistor, which is already labeled here. This is the graph of the resistor, and we can find out what is the value of current when voltage of resistor is 6 volt. So voltage across the resistor when it is 6 volt, we can find what will be its corresponding current. And it is clear that the current value which is on y-axis is 0.4 ampere. So we can write the current value or current passing through the whole circuit when the voltage across the resistor is 6 volt is 0.4 ampere. So now there is very important point you need to understand, that there is a current of 0.4 ampere is flowing through this circuit in this given case. So 0.4 ampere current means the same current will be passing through all the components as they are connected in series. So the current passing through the resistor is 0.4 ampere. The current passing through the thermistor is also 0.4 ampere. And the current passing through the lamp is also 0.4 ampere. And at this case, the voltage across the resistor is 6 volt. Now we can find out what will be the voltage across the thermistor, let it be V2, and what will be the voltage across the lamp, we can consider as V3, when there is a current of 0.4 ampere passing. So we can look at the graph again and we can check when the current 0.4 ampere passes, what is the voltage across the filament lamp. So we just need to find what is this value or the x-axis value for filament lamp when current is 0.4 ampere. So when the current is 0.4, connect to the graph and find what is its corresponding x-axis value, and we can see it is exactly 3 volt. So we can understand the voltage across the thermistor is 3 volt. Sorry, filament lamp is 3 volt, not the thermistor. So the filament lamp is 3 volt. Likewise, we can find out what is the voltage across the thermistor. For that, we need to look at the graph of the thermistor and we have to find at which point when the current of 0.4 ampere flows, what is the voltage across this thermistor. So just find the x-axis value and it is 9 volt. So the voltage across the thermistor is 9 volt. So we have when a current of 0.4 ampere flows, the voltage across resistor is 6 volt, voltage across thermistor is 9 volt, voltage across lamp is 3 volt. So the total voltage of the power supply will be the sum of these potential differences across each component, that is 6 volt plus 9 volt plus 3 volt. So that 18 volt. So it is a 4-mark question. We need to write enough steps. So the first step we can write the current in the circuit is 0.4 ampere. As the same current flowing through all the components, potential difference across thermistor is 9 volt. Likewise, potential difference across the lamp is 3 volt. Therefore, the total potential difference or the PD across the power supply is the total potential difference across all the components in the circuit. So that will be 6 volt, the potential difference across the resistor, plus 9 volt, which is the potential difference across the thermistor, plus 3 volt, that is the potential difference across the lamp. So we will get 18 volt. So the answer is 18 volt. That is the total voltage given to the circuit by the power supply or the cell. Part B, describe the practical use of for a thermistor. So the basic working principle of a thermistor is its resistor value changes according to the change in the temperature. So we can write any sensible use which relates the temperature control or depending on the temperature. So one example we can use for fire alarms. Since it is 1 mark question, only one answer is enough. Question 10 part A transformer has 500 turns on the primary coil and 25 turns on the secondary coil. The input voltage is 120 volt. Calculate the output voltage. So we are provided with the NP, that is the number of turns in primary coil, and NS, number of turns in secondary coil, and the input voltage, that is the voltage at the primary coil. We need to calculate the output voltage or the voltage at the secondary coil. So we can write the equation, transformer equation, which relates the voltage and number of turns, that is Vs over Vp is equal to Ns over Np. And in order to calculate Vs, we can make Vs as the subject. So we will get Vs equal to Ns times Vp over Np. And we have the values where Ns is 25 times Vp is 120 over Np is 500. And the answer is 6. So the output voltage will be 6 volt. This is a step down transformer. The current in the primary coil is 125 milliampere. The transformer is 100% efficient. Calculate the output current. So the transformer is 100% efficient means there is no energy loss. So that means the power input will be equal to power output. Where what is the equation of power? Power is nothing but voltage times current. So we can use this equation here. So input power will be the product of input current times input voltage, and output power will be the product of output current times output voltage. So here the input current is given, that is 125 milliampere. We can substitute that. So input current is 125 where milli. So milli means 10 to the power minus 3 times what is input voltage. Input voltage is nothing but the voltage at the primary, which is 120. That means be equal to output current, which we don't know, times output voltage, which we calculated in the previous session, that is 6 volt. So in order to calculate output current, we can make I out as a subject. So we will get 125 times 10 to the power minus 3. That is the current in primary coil times 120, that is the voltage in primary coil, over 6, that is the voltage in secondary coil. And the answer is 2.5 ampere. So we can write the output current is 2.5 ampere. Part B. Figure 10.1 shows a loose wire connected in a circuit with a DC power supply and a switch. The length of the wire between the two supports is in the magnetic field of a horseshoe magnet. So there is a loose wire which kept in between magnetic field. As you can see, there is magnetic field, so there will be magnetic field lines from north pole to south pole. The power supply is switched on and the wire moves down. On figure 10.1, draw an arrow on the wire to show that the direction of the current. So the power supply is switched on. So here we should understand that when there is power, the wire moves down. That means there must be a downward force acting when the switch is on. So we can understand the direction of force is downward. That is the first direction we can identify from the question. And the second direction is the direction of magnetic field, which will always point from north pole to south pole. So the direction of magnetic field is backwards, or we can consider as into the page. Then we can find what will be the direction of current flow. If we know these two direction, that is the force and magnetic field direction, what will be the direction of current flow? So here we can use Fleming's left hand rule. Why we are using Fleming's left hand rule is that the power supply is already there. We are not generating any current. So it's not a generator effect, as there is no power we are generating. We already have a power supply. So we need to understand there is no power we are producing. So this is not a generator effect, but it is a motor effect, as there is a force is generating here. So such cases it's a motor effect. So we should use Fleming's left hand rule. In the questions, when there is a current produced, in such questions there won't be no power supply. So in that case we have to use Fleming's right hand rule. But here, as already there is a power supply, power is not generating, so this is not a generator effect, but it is a motor effect. So we can use Fleming's left hand rule. And according to Fleming's left hand rule, the thumb represents force always, and the second finger represent the direction of magnetic field, and the third finger represent the direction of current. So here we have the direction of force, that is downward. So your thumb should point downwards, and direction of magnetic field also we have into the page. So the second finger should point into the page or away from your face, so that we can find what will be the direction of the third or middle finger which is pointing. And you can see your third finger will be pointing from right to left. That means in this direction. So from this you can understand that the current must be flowing from left to right in this direction, because your third finger will be pointing in this direction. So you should put an arrow to indicate the current is flowing from left to right. Part 2. The power supply is switched off and the wire returns to its original position. The power supply is then switched on so that the current is in opposite direction. State and explain what happens to the wire. So now they changed the direction of the flow of current. So instead of going from right to left, the current is now flowing from right to left. So what will happen to the wire? When the current direction changes from left to right, the force will be in opposite direction. Instead of downwards, there will be a force which will act upwards, so that the wire will move upwards. So we can write down wire will move upwards. Since it is 2-mark question, we can write the reason also. Reversing the direction of current reverses the direction of the force. Part C, a split ring commutator is an important feature of a DC motor. Suggest one reason why the DC motor cannot operate without a split ring commutator. So the reason is coil does not continue to rotate in the same direction. Question 11 Part A. A detector of radioactivity is placed in a laboratory where there are no radioactive samples. A student notices that the detector shows a count rate that varies between 20 counts per minute and 24 counts per minute. Suggest a source of these readings. So even though there is no radioactive sample kept in the laboratory, since the detector shows a reading, what is the reason? So this reason or this reading is mainly due to the radiations present in the atmosphere or the surrounding, and it is called background radiation. Since it is 1-mark question, this is enough. Part 2, explain why these readings are not constant. So it's mentioned these count rates are varies between 20 to 24. So why it is fluctuating? The reason is the radioactive decay is random. That means we cannot predict. Where the word random is very important keyword, you should write this word in order to score mark. Part B. A nucleus of uranium contains 92 protons and 146 neutrons. It decays by emitting an alpha particle to become a nucleus of thorium. Complete the nuclide equation for this radioactive decay. So, the atomic number is nothing but the proton number, which we can write at the bottom side of the symbol, and the proton number is given, which is 92. Proton number plus neutron number, that is the mass number, which we should write here. So the proton number is 92 plus neutron number is 146, which is 238, which is the mass number. So we can write 238 here. And when it decays alpha particle, we should know alpha particle is equal to an helium nucleus, so that its proton number is 2 and mass number is 4. So in order to balance or equalize the LHS and RHS of the equation, what should be the value of the proton number of thorium? That must be 92 minus 92 minus 2, so we will get 90. So that for thorium, its proton number is 90. So we can see the total at the RHS is 90 plus 2, 92, and LHS is also 92. So this equation balance. Likewise, we can look at the mass number. So at the LHS it's 238. So RHS also the sum should be 238. So in order to balance, the thorium should have a mass number that should be 338 minus 4. So we will get 334. So 334. Now you can check the mass number at RHS is total mass number is 234 plus 4, that is 238, and even at LHS is also 238. So now the mass number and atomic number balances. Part C, an isotope of radon has a half-life of 3.8 days. It decays by emitting alpha radiation. Calculate the time taken for 60 milligram of this isotope to decay to 2 milligram of this isotope. So we need to find out, we have 16 milligram of radon, and in order to reduce this to 2 milligram, how many half cycles it has gone through. Then we can easily calculate the time taken. So first, in order to become from 16 milligram to half of 16, that is 8 milligram, it will take 1/2 life. Then from 8 milligram to 4 milligram, half of 8, it will take another half life. Then from 4 milligram to become again half of this 4 milligram, that is 2 milligram, it will take one more half life. So total 3 half lives required to decay from 16 milligram to 2 milligram. Therefore, the total time taken is nothing but 3 half-life. That means 3 times the half-life is given, which is 3.8 days. So 3 times 3.8 days, that means 11.4 days. So in two significant figure we can write 11 days, where the days is already given.